Ignition sequence starts.
Good morning. You're looking at the International Space Station Flight Control Room at NASA's Johnson Space Center, where the flight controllers are monitoring station systems and assisting the Expedition 64 crew members through the last few hours of their regular work week. The team on orbit kicked off the week watching the first automated docking to the station by a SpaceX cargo ship, and then got busy unpacking the crew supplies and science materials inside.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Katherine Clayton. There's more science to get excited about with the arrival of the new SpaceX Cargo Dragon. On Sunday, SpaceX launched their Commercial Resupply Services Mission 21 to the International Space Station from Kennedy Space Center in Florida. The upgraded Cargo Dragon delivered more than 6,400 pounds of research, crew supplies, and hardware. The autonomous docking was a first for the Cargo Dragon and was monitored by astronauts Kate Rubins and Victor Glover aboard the station. The Cargo Dragon will join the Dragon Resilience that delivered the Crew 1 astronauts to the station last month, marking the first time there are two Dragon spacecraft docked to the station simultaneously. The Cargo Dragon will spend approximately 1 month attached to the space station before returning to the Earth with cargo and research. CRS-21 delivered exciting science investigations that will help us understand the human body and how we adapt to different environments. The effect of microgravity on human brain organoids will observe the response of brain organoids to microgravity. Brain organoids are small living masses of cells that interact, grow, and can survive for months. They help us understand how larger systems react to changes in the environment. The investigation will expose the organoids to microgravity for 3 weeks in the Space Tango Lab. NASA is always preparing for further exploration, and 2 investigations delivered on CRS-21 will make that exploration possible. The bioasteroid investigation will study the process of how microbes form layers on the surface of asteroidal material and how the microbes alter the release of elements from the rocks. Bioasteroid will also study biofilm formation and elemental release in microgravity to investigate how space conditions ultimately affect microbe and mineral interactions in space. Deep space exploration will require human space habitats, and the brazing of aluminum alloys in space investigation, or SubSabrains, will examine a potential tool for the construction of human space habitats. Liquid metal formed during a process called brazing bonds materials at temperatures above 450 degrees Celsius. The results of this investigation could enable brazing in space structures and repairs. Keep sending in your questions using the hashtag AskNASA, and we'll see you next week.
Flight engineer Kate Rubins is both a scientist and a NASA astronaut, and there's no better place to be for someone with those 2 job titles than aboard the International Space Station. Rubins says being free from Earth's gravity makes the outpost the perfect place to conduct research.
The reason that you would do any kind of experiment in space is if there's something particular about the space environment, and most often that is microgravity. So mostly the ISS gives us the ability to either do something that we can't do in a facility on Earth or investigate some phenomenon, some property in a way that we can't on Earth. So for example, some of the tissue architecture, these really delicate tissues, as you start to build them up, they would collapse because you have gravity, or the cells would naturally settle to the bottom of the plate. And so you just can't study the answer to the question that you're looking for. So the space station lets us have that ability to either test what the effect of gravity is or remove that problem entirely from our experimental setup. Yeah, the space station's an incredible place to conduct research. It was sort of like being in the world's most amazing lab when I was up there in 2016. So when you're a scientist, you're used to working on one thing over and over and maybe really refining the details on that over the course of a PhD thesis or a lab project. On Space Station, you get somebody's incredibly refined project times 200 different fields. So for me, it was a chance to learn about all these different areas of science, and they each have a team behind them. So I was usually pretty excited to open the container and do whatever experiment that day brought. I also really got a chance to talk to those PIs, the principal investigators, and those scientific teams, and understand everything that was going on behind their experiments and read their papers. So by the time I got to doing the experiment, I was pretty excited to take it out and to see what was going to change in microgravity. Yeah, science in space, it's an amazing lab and it's incredibly fun. So we are smiling all the time. I'm Kate Rubens. I'm a scientist and an astronaut.
The International Space Station hosts experiments in a wide range of scientific disciplines. How about research into using 3D printing technology, which could allow cell growth in 3 dimensions?
Cutting-edge biomanufacturing aboard the International Space Station. Presented by Science at NASA. Most likely, you're aware of 3D printing, which allows you to design and produce one-of-a-kind pieces for a variety of purposes. But what if you could use that same technology to manufacture biological materials, like new tissue or blood vessels? Welcome to the world of 3D biomanufacturing, a cutting-edge practice on Earth that is being tested aboard the International Space Station, or ISS. Dr. Mike Roberts, Deputy Chief Scientist at the ISS U.S. National Laboratory, explains why the space station is critical to biomanufacturing's future. We've been able to grow cells in a lab for well over a century, but gravity limits that growth to 2 dimensions. Cells can grow outward, but not up and down like they do in the human body. Also, lab cells are often in contact with the glass or plastic that contains them. But aboard the space station, our experiments will be conducted in microgravity. That allows you to build your cell models in 3 dimensions, without being confined to the bottom of a dish, or unable to grow in contact with lots of other cells. Biomanufacturing imagines the ability to someday grow a viable human organ. Organs are composed of specific tissue intersected by blood vessels. Most organs and thicker tissues in the body have a rich, complex network of blood vessels that provide nutrients and remove wastes from the living cells that make up the tissue. We currently lack the ability and the tools to engineer these highly branched, living networks of vessels inside layers of tissues on Earth. Another medical advantage to manufacturing biological parts in space is the potential to bypass the body's immune system. Today, organ transplants from donors are prone to rejection because the patient's body perceives the new organ as a foreign object, and their immune system tries to attack it. But with the ability to grow tissue in space, a person could conceivably have their own cells used to make their new organ, which might avoid the body's rejection. 3 different types of biomanufacturing facilities will be tested aboard the space station. 2 of them perform in a manner similar to a standard 3D printer. They extrude cells in layers to build tissue. The 3rd type uses powerful magnets to position the cells in place. Each of these 3 different approaches to bioprinting in microgravity will be available to medical researchers seeking to better understand how to engineer tissues and organs for use in repairing injury and curing disease on Earth. As Dr. Roberts notes, the 3D bioprinters represent cutting-edge technologies that could clearly benefit health outcomes on Earth. I think the ability to manufacture a fully functioning human organ will take some time, maybe a decade or more, but the knowledge we'll acquire to get there will also create interim benefits as we learn more about cell regeneration in space and its application to humans on Earth. For more inside information about studies inside the station, visit www.nasa.gov/ISS-science. For more on science happening on, around, and beyond our planet, go to science.nasa.gov.
From week to week, we show you examples of the science research being done on the International Space Station. In the 20 years that people have lived there and worked in that laboratory, there have been thousands of scientists involved. Here's a look back at some of them.
When we are called to do an experiment, sometimes it's a very short lead time. We get a 12-hour call and we're in.
My advisor and I, we have to work together. He's talking to the astronauts, I'm talking to the cadre, and so it's really difficult to take it all in.
Very nice, very good. Try not to break them up, but that's a very good disturbance. And now back and forth the opposite direction.
What's funny is I forget who I'm talking to sometimes. I'll have conversations where it's like, oh yeah, you know, we had an experiment yesterday, it was on the space station, we were talking to the astronaut, Doug, and it's so casual. And it's like, most people are like, what do you do?
Throughout this season of NASA Explorers, you've seen what it takes to send science to space through the eyes of one team of researchers. But they aren't the only ones. For 2 decades, the International Space Station has hosted science from thousands of researchers across the globe.
The importance of the ISS to the research community is huge. From the very basic phenomenon of taking gravity out of the equation is that the ISS is really the only platform we have right now that gives you access, long-term access, to a microgravity environment.
You can do the experiments, on Earth, but those are almost a precursor to, okay, now let's remove gravity and see what happens. Does it change?
If you're like me, you're a scientist who's trying to unravel the mysteries of science, and someone shows you a shiny new tool, which is microgravity, which can, make science different. And different is what we constantly shoot for.
And different can take time. Before new scientific discoveries could be made, we had to transform an orbital outpost into an orbiting laboratory.
In the early days, it was so focused on building, constructing station and making things safe. And then we started stepping up the number of hours a week that we could use crew time for experiments and research.
That was a very exciting time. The space station would have more capabilities for science. They would have more equipment up there. They would have, freezers, glove boxes, microscopes, etc. Things that we could use to extend the scope of our science.
Space station became a laboratory. It lent itself very well to this concept of fly an experiment, you get the results back, just like you would be in your own laboratory at home. You get more questions as well as answers.
And during that time, a lot was learned. A lot of surprising things were learned. And with that knowledge now, we're developing experiments that are much more advanced in terms of their engineering application.
It's been an extraordinary journey to watch over the past 20-odd years how this has all kind of come together and become, I wouldn't say routine, but accessible. And that's a really powerful thing.
The same thing that gives us new insights also creates unique challenges. Microgravity changes the way everything works, including science.
Working in space, as you can imagine, has a lot of challenges. Everything has to be compact. If you're gonna send something into space, it has to be small. And how can you fit an entire lab bench worth of science into something, your size or your hand? And yet, we still get great information. We still, are discovering things, all the time, and I think it's incredible.
Up till the NASA twin study, I was an Earth investigator. The biggest adaptation that I had to make was, on Earth, there's an ample supply of all the tissue that you need, whether you need blood or you need urine. So we had to work together and figure out a plan on how to use 1 vial of blood instead of 10 vials of blood. The stress of these precious, this is the most precious samples I've ever worked with, was kind of novel.
There were different students that all got together to create this project. It was really stressing on every review because, of course, you're they're gonna say everything's wrong and they're gonna blame it on me or whatever. We knew that it would be difficult, but everybody that jumped into the project pulled through, and at the end, we achieved a successful mission. So I think that's awesome.
What we've learned from more than 3,000 space station experiments is helping us back here on Earth and on our quest farther into space, to the Moon and Mars. These experiments are aiding drug development to fight diseases like Alzheimer's and Parkinson's. We've learned about combating bone and muscle loss, which could assist people suffering from osteoporosis. We've tested how to grow plants in microgravity, a critical component for feeding future space explorers. None of this would have been possible without the astronauts, the humans living and working aboard the International Space Station.
Having the astronauts there to help us was a critical part of being able to do more complicated science, to get higher science yield out of the science that you were doing. They were incredible as people who were there to troubleshoot your experiment should you need anything.
You can never replace a set of human hands. I don't care if it's on station, on the moon, on Mars. There's just something that people can adaptively do that you'll never get a machine to do.
You can collect a lot of data with robotic sensors, but there is still a very big role for humans to play in being able to make on-the-fly decisions.
Yeah, that has a little bit of a bubble on the end. Do you want me to force that out?
If it's possible, if you think you can do it with the tip, yeah, we would appreciate that. At this point forward, this is our DNA to sequence, so the most we can retain, the better.
It was rewarding to be able to put my hands on and know that we're doing productive work. Sometimes we get thrown a curveball and something goes wrong.
Station, Huntsville on 2 for TJ and ABRS.
So now they go, all right, we got to get you to go into the guts of this thing, go find these 2 wires. Have you ever seen those scary movies where the bomb diffuser says, whatever you do, don't cut the red wire? That's kind of what it feels like. You've got somebody who's spent their life developing the research that you're working on, and you're about to go into the guts of his experiment, trusting you very well to do the right thing and not cut the wrong wire. But that's the kind of stuff we need to do when we start going farther and farther away, when we start encountering anomalies we didn't think were likely. And so the crew has to be able to be adaptable to be able to do that. And that was really exciting and fun to be able to accomplish.
TJ, we copy that, and who would have thought a blown fuse would make so many people so happy?
Jeff happened to be orbiting and looked outside the window and saw this eruption just happening. And then he said, hey, I wonder if anybody knows this volcano is erupting. And so he actually called the USGS and said, hey, I see a volcano erupting. Do you guys know about it? First, he had to convince them that he was actually who he was and was actually calling them from the space station. But once you get past that, they then confirmed with other data, like, well, you're right, it is erupting.
So I think those are some of the ways in which the astronauts just play an incredibly valuable role when they're up there helping us with the experiments that we do.
These past 2 decades of microgravity science, they're just the beginning, the start of humanity's continuous presence in space. And the impact of the research in this novel environment is already being felt around the world.
I think most people would not realize how impacted their life is by space. There's a finite number of experiments, but that is a finite number of experiments in a very, very smart community that's very good at sharing the results. There is a real sense of the betterment of humanity in space. You know, it's one place we can all really collaborate and all really get along.
I think it's safe to say that microgravity has allowed writing several new textbooks.
And the more we have more and more scientists working in different arenas to help inform this science, I think the better it will be for the safety and health of the astronauts and the people that follow. We are just at the tip of the iceberg. We have a lot more information that we're going to find out, a lot more information that we're going to need to find out in order to get us prepared for long-term exploration, as we humans are always excited to do.
Space Station now is acting like a test bed, a proving ground for new development, new system hardware, as well as how we're going to be doing research and what kind of research we want to be able to do in a near environment, 240 miles above the surface, versus seriously long distance away where there's time delays up to half an hour-ish that we need to be practicing for, and now's the time to be able to do that.
You know, I would say before I started working at the lab, it was kind of an abstract idea, and there was always the joke about, oh yeah, humans will go to Mars, and it didn't really feel real. And now it feels real, and what's incredible is, you know, I will have a piece of that.
I like to think that some of the work that is being done on the space station lays the foundation for us to be successful on another planetary surface. Will I ever get there? No, it's not likely. But I do hope that someday that somebody thinks back on, wow, it's really great that we learned about X, Y, and Z things from the Paul and Furl research, because we'd never be successful on Mars without it.
We'll learn more and more the farther and farther we go. The first stepping stone, though, is the proving ground that we're calling International Space Station.
Being the hands in hands-on science research is one part of the job description for an International Space Station crew member. The astronauts and cosmonauts share the experience of being in space with us Earthlings, and they talk to students about key scientific concepts, as astronaut Mark Vande Hei demonstrates in this demonstration video.
Welcome to the International Space Station. I'm NASA astronaut Mark Vande Hei. Today, we're going to talk about Newton's third law. How do you think it will hold up in microgravity?
For every action, there is an equal and opposite reaction. This means that in every interaction between two objects, there are a pair of opposite forces acting on each object at the same time. A force pair. You can see that there are many examples on Earth. In space, thrusters expel one way and the vehicle is steered in the opposite way.
Hello again. More basketball stunts that I can't do on the ground, at least not while getting this much hang time. All right, back to serious business. Got a basketball right here. It's going to be object 1. I'm the second object. If object 2, myself, applies a force to object 1, then that same force will be applied, according to Newton's third law, by object 1 onto object 2. However, there's a big disparity in the mass. Object 1 is a very light mass object. Object 2, myself, is a larger mass object. So I'm going to try to make myself about the same shape as this ball. See how that works for us. And I'm going to apply that force. You saw that force applied to the ball made it accelerate quite a bit. It really didn't accelerate me much at all. Newton's third law again, but this time we're going to use two similarly massed objects. Joe and I have about the same mass, so Joe, get into a ball. I'll do the same. I'm going to face you this way so that I don't throw you into something you can't see. Now I'm going to get into a ball behind Joe, and I'm going to apply a force to him. Notice that when I applied a force to Joe, it accelerated Joe away from me, but I got accelerated away from him as well, because the force applied to Joe ended up being the same force that was applied to me. Now you've seen Newton's third law in space. Now test it out on Earth. See you next time.
Future NASA missions, like the ones that will return American astronauts to the moon in a few short years, are part of NASA's Artemis program. Here's a look at the progress on hardware being made at NASA's centers and contractor locations all across the country. If you want another look at any of the stories we featured today, head over to YouTube or Facebook. And if you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast. Today, Gary Jordan talks with the experts about the skills that astronauts need to contribute to the success of high-performing teams. Go to nasa.gov/podcasts for this week's episode, all the previous episodes too, and the full library of all NASA podcasts, which are also on Apple Podcasts, Google Podcasts, and SoundCloud.